Hey everybody, Jeffrey Powers here, Build Day TV. I'm here with my friend Alastair Cooke, all the way in New Zealand. How's it doing? How's it going there in New Zealand?
It's a beautiful winter's day here in New Zealand. The sun is shining and it's not raining, which is a nice change.
Awesome. So today we're talking about AWS networking like we have been in the last few weeks. But this one we're talking about linking two VPCs together. How does that work there, Alastair?
Well, we've looked at a VPC in our earlier episodes and seen that it's a container for a bunch of virtual machines, EC2 instances, and an application. But what we haven't looked at is why you might have multiple and how you make multiple of these things go together. On premises, data centers are really expensive and huge, and so we put everything inside one data center. But we might have multiple virtual private clouds. Now, we treat them like a data center, but they're more of an application location for a lot of organizations. And so quite often, each team that has to build their own application will have their own virtual private cloud, their own VPC. And so you'll have multiple VPCs for multiple teams, or maybe you'll have even separate AWS accounts. And that gives us an even stronger security boundary between these teams.
Okay.
We might have one team, one AWS account, but have these data centers spread around the world. And so in different regions, we'll have multiple VPCs because a VPC lives inside a single region. So my own VPC in Sydney is completely separate from my own VPC that maybe is in Ohio.
Okay.
These are two different AWS regions, so we'd have multiple VPCs.
And we talked a lot about regions last week in that episode.
We did. Yep. We talked particularly about availability zones within a region. And we'll talk some more about that and further. When we talk about the AWS global infrastructure, that's a good time to talk about regions and availability zones and those kinds of things.
Okay.
Sometimes we also want to connect our applications beyond our own organization. So we may have other organizations that we work with, other companies that we work with, and we need to have some sort of private network connection between them. So we sometimes have this with partner organizations. Sometimes we need separation for compliance reasons. I've seen situations at, for instance, a merchant bank where they needed to separate out the entire part of the organization that provides advice about financial services from the organization that delivers financial services. And multiple VPCs is one of the ways to do that. And then we also often will want to separate things for security reasons. So there's a whole bunch of really interesting designs for networks that are set up in order to provide higher security. And a lot of them work with multiple virtual private clouds, multiple VPCs.
Okay.
So there are a host of reasons why a medium to large organization might use multiple virtual private clouds. And then might want to join them together into one large, essentially wide area network across these multiple VPCs.
Okay.
Now we'll look later at joining these to your on-premises network, but just for today, we're going to stick with connecting things that are inside AWS. And we're going to do this one of two ways. Now, one of the ways you can provide connectivity between your VPCs is to use the public side, use the internet gateway and the NAT that's involved in the internet gateway, and access from one VPC to another through those public IP addresses, the same as you'd access these applications from the internet. So it is absolutely valid to provide connectivity into your VPC from the public side and provide access to applications the same way as you do for public access to this.
Okay. But
often we want private side connectivity. So we don't want this communication going across the internet because maybe we've got some security requirements. Maybe we just don't want to expose the resources that we need to connect to out to the internet. And this is why we have private side connectivity, where we route through those private IP addresses. Rather than connecting to the public IP address, you're connecting on the private side. And so this never traverses the internet. It is still controlled with security groups. We saw in our second video we did, Jeffrey, where we did the firewalls. I think it was the second.
Yeah, the firewalls were the second episode, yes.
Yeah, we saw security groups. So we saw the ability to use security groups to restrict what can connect in. We also will see that we can use route tables to control how network traffic flows between these VPCs as well. We can't control traffic inside a VPC with route tables, but between VPCs we can. So what does this look like? Well, we have this idea of VPC peering. So establishing connectivity between two VPCs on the private side is done using this functionality called VPC Peering. And it's a one-to-one relationship between a pair of VPCs. One of the really important things about VPC peering is that the way the routes are set up is non-transitive. So what does that mean? Well, if I've got three VPCs here, VPCs A, B, and D, and I establish a peering connection between A and B and another one between B and D, A cannot talk to D through this peering setup. This is what we mean by transitive. The traffic coming out of VPC A cannot go through VPC B and land in VPC D.
All right.
In order for VPC A to talk to VPC D, we would need another peering connection between A and D.
Okay.
Okay, so this is what non-transitive means here. But it does work with full IP routing. So this means that we are making one whole routed network amongst this collection of VPCs that we have joined together with peering connections. And very importantly, the IP address ranges must be unique for each VPC. Remember when we created our VPC in the first episode, we had to specify an IP address CIDR range? Right? Those must be unique across all of the peered VPCs. And then we update the route tables on each of our subnets to talk to the other VPCs. So what we're doing is setting up an entire, essentially a wide area network across these VPCs. Even if they're potentially in the same region, it functions the same way as a WAN would for a larger organization.
Okay.
And we can join VPC peering across all kinds of different structures. So we can have VPC peering for multiple VPCs within one region or between multiple regions. We can also peer VPCs from one AWS account to another and across different organizations within AWS. So a company might have 15 different AWS accounts and peer all of those together, but they might do business with another organization and they might peer some of their accounts in their organization with some of the other company's accounts. So we can go, but it doesn't matter who owns the actual AWS account. We can peer between VPCs and multiple AWS accounts across multiple regions. We'll see this gets really complicated.
Yeah, I can imagine not only being complicated, but also being somewhat problematic as you have non-transitive VPCs not talking to areas that you need it to talk to.
Yeah, and so because we have to do that explicit mesh, it's really easy to just miss something off by accident, particularly if you're doing this all manually in the console and making changes to route tables directly. Yeah, This gets really messy as it gets large, and I'll call this out as we go along. But yeah, there's this thing called transit gateway, and we'll talk about transit gateway in another episode because it helps us when things escalate. But it's important to start with peering.
Okay.
So to establish a peering relationship between two VPCs, one of the VPCs requests the peering connection, and it simply has to know the ID of the other VPC. Right, so VPC dash some long hex string. Right, that's all you've got to know.
Okay.
So one side requests, and then the other side has to review and accept the request. Now, normally this happens because you've already been talking with whoever owns the other VPC, or you own both of them. That's what I'll show you in the demo in the next video. But it can be between different organizations, completely different administrative structures. So that separation of you must request and the other side must accept allows that mutuality of having this connection set up.
All right.
Once the peering connection has been accepted, the peering connection object actually is created and has its own identifier. And just like we've changed route tables to point to internet gateways or NAT instances, we're going to change route tables to talk to the peering connection rather than a particular IP address as the destination for things.
Okay.
So we might have a VPC called pizza, and it might request a peering connection to a VPC called pasta. On the pasta side, there will be an acceptance of that peering connection. Then the peering connection comes in with a peering connection ID, that PCX-some hex. That's the process for creating the peering connection. The result is that these two VPCs are then paired together. Naturally, you can see that the CIDR ranges here, the 1064 at the top and the 1012, they don't overlap. Their network addresses are unique, and so we can set up routing between them. Now, just because the peering connection's up doesn't mean we've got traffic flowing. Sorry, Jeffrey, you had a question there?
Well, I'm trying to understand this whole thing. So let me just throw an idea out there.
Yeah.
So if you have, let's say you have a pizza place and you have two locations and one is called Big Al's Pizza, but the other place, there was already a Big Al's Pizza. So you have to say Alastair's Pizza. You could share the data and still have Big Al's Pizza on one and Al's Pizza on the other, right? Am I thinking of that correct?
Yeah, that's absolutely right. At the network level, we're establishing connectivity between those two different businesses, those two different brands.
And then that shares
allowing network connectivity between them.
And that shares the data. So if you change the price on one pizza at Big Al's, Alastair's Pizza will have that same price.
Yeah, and so what we might have is that there's a database server in Big Al's Pizza that holds all of the pricing. And so the website in the Big Al's Pizza VPC queries this database for pricing. But what was the name of the other pizza place?
Alastair's Pizza. I made it simple. I couldn't even remember it.
In the VPC for Alastair's Pizza, the actual web server still queries back across the peering connection to get to the database server in Big Al's. Right, so because that peering connection is in place, we can do a private connection across to that database server in the other VPC to get the same data. So yes. Yeah, absolutely. You could. This would be one of the ways of implementing that. And the good thing is that database server that has all the pricing information isn't accessible from the internet. This is why we've used a peering connection rather than going out on the public side.
Oh, okay. All right. Now I'm hungry, so let's feed me more data.
Once we've set up the peering connection, we haven't actually allowed any connectivity across that connection because none of the subnets in our VPCs know about the other subnets.
Okay.
And so they don't know to send any traffic across. And so we have to update route tables in our subnets. And so you can reach this other subnet through this peering connection. So every subnet that's going to access something on the other side of the peering connection needs a route through that peering connection to the other side.
Okay.
And then the other side needs a route back again because you've got to send the request out and the answer's got to come back. So you need route tables on both sides changed before connectivity is established.
Okay.
Most often, we will specify for every subnet on one side of the peering connection, we'll just specify the CIDR range of the other VPC. And we'll allow full access. But usually we set the route tables up to say, if you just need to get to anything in the other, the pastor VPC, just go through the peering connection. It doesn't matter what inside.
Okay.
But we can be more selective about this. We don't actually have to put those routes on all of our subnets. So we might have some subnets that we don't want accessible across this peering connection. This is most often the case when you peer with somebody who is not the same organization as you. So you may have a small amount of the resources in your VPC that should be accessible to a partner organization. You peer the VPC with the partner organization, just that subnet that contains the small amount of resources that the partner can access gets a route to their VPC. All of the resources you don't want them to have access to, you simply don't add a route back to their VPC.
Okay. So if there's a special pizza in New Zealand that's not in Australia at Alastair's Pizza, then Alastair's Pizza doesn't see it.
Yeah, and really importantly, this is done at the subnet level.
Okay.
So it's not inside the EC2 instance. It's done in the networking stack here. Now, we still also get the ability to control things using security groups. So we do also need to open up those firewall rules. So we have multiple layers of control.
Okay.
So our example might be that we have two VPCs here called pizza and pasta. I'm really trying to make Jeffrey very hungry here.
Yeah.
And we might establish a peering connection between the two. And then start setting up some route tables. And so we set a route table from pizza private 1 to talk to pasta private 1 over the peering connection. And we tell pasta private 1 to talk back again. We're making a change on every subnet that needs to be able to traverse this peering connection. Now, here I've got 2 different subnets on pizza private that I've routed through the peering connection. It would probably be simpler just to specify the entire CIDR range of the VPC rather than the individual subnets.
Mm-hmm.
But coming back from the pasta VPC, I'm only allowing the pasta VPC to talk back to the pizza private. I'm not having the route to the entire VPC here.
Interesting.
Okay, so the pizza public subnets, pizza public subnets, I wrote these slides a couple of days ago. The pizza public subnet doesn't get any routes across into the pasta VPC. And so in this way, the pasta VPC can't access the pizza public subnet over that peering connection.
But it does talk, it talks to the pizza private one, but it doesn't talk
pizza
to
public and pizza private can talk to each other.
But
and pizza private can talk to both pasta subnets.
Okay, but pizza public cannot talk to pasta public, pasta private.
Correct.
Okay.
I could have diagrammed this differently with different route tables in here. The important thing is that if the pizza public subnet doesn't have a route to the pasta VPC, then the pasta VPC can't talk to the pizza public subnet.
Okay. But you could set it up where everybody's talking to everybody, and you can take
Absolutely.
out, yeah. And then you could probably take out, I'm guessing, you could take out, pizza private could talk to pasta private, but pasta private can't talk to pizza private. And yeah, and just make a real mess of that. Okay, perfect.
Subnet by subnet. And you might do this by accident. This is one of the joys as this thing scales, is you might accidentally miss one of your subnets.
Oh, trust me, I would be doing it by accident. But let's continue.
And that's where the scalability challenges with VPC peering come in. When we've got 2 VPCs, things are fairly simple. But when we've got multiple VPCs that we want to join together, then it's multiple one-to-one relationships. And every subnet in every VPC has route tables, and they have to know about every other VPC that they're going to route to.
Okay.
It becomes a management and troubleshooting nightmare as this thing scales, because if we start thinking about an environment that's got 10 VPCs, well, each of those 10 VPCs connects to 9 others, and there are 45 peering connections to be maintained across these 10 VPCs.
Okay.
Because it's a full mesh, every VPC connects to every other VPC. And that means that each subnet has at least 10 route table entries in it. Then multiply that by 10 VPCs, multiply that by the number of subnets per VPC. Yeah, this scales really badly. It gets extremely painful. And you really do want automation to handle this for you if you're doing this at scale.
Yeah, I could see a lot of, even with automation, you'll run into problems where you have to back up and start over again, I would guess.
Yeah. And you'll hit exceptions as well, because although you may have a standard of we're going to allow everything on our inside of our corporate network to talk to everything else, you'll then start hitting some exceptions where the automation has to handle the exception as well as the standard, and that makes the creation of the automation much trickier.
Yeah.
This is why we like Transit Gateway. But Transit Gateway is a subject for its own video, and we will talk about Transit Gateway. VPC peering is good if you have a small number of VPCs, but it gets to be painful with a large number of VPCs, and then you start considering the Transit Gateway feature instead. So that was the basics of linking 2 VPCs together using VPC peering. You request and accept the request to peer, and then you update route tables, and normally then update security groups as well. Join us for the next video, where I'll get hands-on and actually pair a couple of VPCs together and make some changes to route tables and security groups and make sure we can actually connect across this video. Jeffrey, How was that?
That was awesome. I learned a lot about linking to VPCs and how it works and how you can get into a real mess if you're doing it wrong. That's for sure. So once again, thank you guys very much for being in the video. Remember to follow, subscribe, and follow this playlist because that'll take you right to the next video as it goes. Unless you're watching it in our premiere, and then of course you got to wait for the next video, but that's okay. It'll only be a few minutes away. So go ahead, like, subscribe, tell all your friends, and let them know about Build Day TV. You can also follow us on Facebook. You can follow us on the Reddit page at Build Day Live, and Twitter at Build Day Live, and go from there. But for now, thank you guys very much. This has been episode 5A, linking two VPCs together. Thanks, Alastair, for your time, and we'll see you next time.
Thanks, Jeff. See you next time.